welcome to Virtual CB1A. This is Ma'am Rena, and for today's lesson, we are going to study how to perform the Euclidean algorithm. So Euclidean algorithm is used to find the GCD of two numbers A and B. This is very useful because from the Euclidean algorithm, you can find a linear combination for the two numbers A and B such that A multiplied by an integer x plus B multiplied by another integer y will be equal to the GCD of A and B. Okay, so let's find the GCD of 15 and 24. So how are we going to find the GCD of 15 and 24 using the Euclidean algorithm? So using other methods, you can use prime factorization or simply visual inspection or simple analysis of the two given numbers, and you can come up with the GCD. It is pretty obvious since you have relatively small numbers that the GCD here is equal to 3. But again, let's use the Euclidean algorithm in finding the GCD of these two numbers. So this is how you do it. Just start with the greater number. We have 24. Then write it using the sum of the smaller number multiplied by the quotient of these two. 24 divided by 15 is 1 plus the remainder. So if you have 15 times 1, how will it equate 24? So you have to add, you have to add 9. After that, take the number here, our first term, 15, or our smaller number from the original pair, and then get the remainder from the previous line, and then divide them. 15 divided by 9 is equal to 1. So write their quotient here and then the remainder. So again, it is the smaller number multiplied by the quotient plus the remainder. We're going to arrive here with 6. After that, take our number from this part. We have 9. Get the quotient of the product and the remainder. We have 9 divided by 6 is 1. 6 times 1 plus 3. And finally, let's have 6. Get their quotient. We have 3 times 2. And of course, our remainder 0. Now, what is the GCD? The GCD is the last non-zero remainder. Okay? So the GCD here is 3. So using the prime factorization method, if you have here 15, let's prime factorize. You have 5 times 3. 5 and 3 are both primes. How about 24? You have here, of course, 12 times 2. 2 is a prime, so let's break down 12 into other factors. We have here 6 times 2. 2 is also a prime. Let's break them up again. So we have 3 times 2. So the prime factors of 5 and 3, prime factors of 15 is 5 and 3. While for 24, the prime factors are 3 times 2 times 2 times 2. So how do we find the GCD? The GCD is the greatest number that can divide both of the numbers. So you have there just the number 3, and for here also just the number 3. If you are going to multiply this by other numbers, say for example 6, it will not be able to divide 15. And for here, if you are going to divide 24 by 5, it is not divisible by 5, so you will not arrive with an integer quotient. Therefore, the GCD is 3. Let's look at another example. After this, we are going to find the linear combination. Okay? So, lagay tayo dito ng isa pang page. Ay, yung dalawa. So, for our next example, let's find the GCD of 323 and 113. Okay? For the GCD, let's take the greater number and write it as a sum of the smaller number times their quotient plus the remainder. So 323 divided by 113. How many 113s are there in 323? So lagay tayo dito, 323 divided by 113. Kasi medyo malaki na siya. You can always use your calculator if you want. So dito, nag-shortcut na lang, nag-calcu ako. So we have 2. And then, ang remainder niya, hindi ko napapakita yung yung process ng quotient, ng pagkuha ng quotient. Since marunong na naman kayo noon, I assume na marunong na kayo. Maipakita na nga. So we have here 226. So subtract natin sila. Ay. We have here 97. So ang remainder niya here is 97. So this is 113 times 2 plus 97. After that, we have to take 113 from here and then write it as a product of our previous remainder times their quotient. How many 97s are there in 113? Let's check. So, syempre, isa lang. 1 times 97 is 97. Get their difference to find our remainder that will be placed in this part. So, we have here times 1 plus the remainder. So, 113 minus 97, you will end up with 16. After that, let's take 97 from here. 97 is equal to 16. Get their quotient. 97 divided by 16. You have there 6. 6 times 16. You have there 96. So our remainder here is 1. After that, let's get the previous value from here and then multiply it by our remainder 1 and then write it as a combination. For here, we have 0 remainder. So the GCD is the last non-zero remainder. The GCD of 323 and 113 is 1. Okay? Let's try another one. 323 ulit, pero palitan natin yung second term. Ayun, dito na tayo. Let's find the GCD of 323 and 133. So again, start tayo sa malaking number and then write the smaller number here. Find the quotient between the two. How many 133 are there in 323? You can get your calculator and solve for this. We have 2 times 133 is 266. Get their difference. We have 323 minus 266 is 57. So from here, you have to write the quotient inside this one, the parenthesis, and then write the remainder in the end. So you have to write the bigger number as a product of the smaller number times their quotient plus their remainder. Now let's take the smaller value from here. It will be our new number. Then write it as a combination of the product of the remainder times their quotient. So what is their quotient? 133. Please look at the right side. I am doing my computation. 133 divided by 57 is equal to 2. 2 times 57 is equal to 114. Get their difference. You will end up with the remainder 19. So write their quotient here, 2, plus the remainder 19. Now, let's take our new number here, the remainder from the first outline. We have 57 multiplied by the product of the remainder and their quotient. So 57 divided by 19. Let's write it here. 57 divided by 19 is 3. 3 times 19 is 57. So you have a 0 remainder. So 19 times 3 plus 0 remainder. So what is the GCD? The GCD is the last non-zero remainder. So the GCD is equal to 19. Okay? Alright. Now, let's go back to our first example because this time we are going to write it as a linear combination. How are you going to write it as a linear combination? Such that, hindi ko siya ma-select. Ayun. Such that ax plus by is equal to the GCD of the two numbers a and b. Baguhin natin yung kulay. Ayan. So, let's find a linear combination for 15 and 24 such that it will be equal to the GCD 3. So, sulat natin. Saan kaya? Bubura ko ng ibang parts. Burahin natin to. Ayan. Sabi nga natin, the GCD is the last non-zero remainder. Isusulat natin siya side by side. So, we are going to start with the third line for our solution, and then we are going to write it as a combination. So this is 9 times 1 minus 6 times 1 is equal to 3. How did we come up with this value? So 9 multiplied by 1 is equal to 6 times 1 plus 3. Using the addition property of equality, we are going to transfer this term here, 6 times 1, to the left side. So kaya siya naging minus 6 times 1. But, since we are looking for ax plus by is equal to the GCD AB, we are going to change this into plus. So we have here 9 times 1 plus 6 times negative 1 is equal to 3. Okay? Next, dun tayo sa pangalawa. We are going to write this line leaving 6 on the right-hand side. So, dapat si 9 times 1, nandun siya sa kabilang side. We have 15 times 1 minus 9 times 1 is equal to 6. Since nakikita nyo na yung pattern, we are going to have here 15 times 1 plus 9 times negative 1 is equal to 6. Dapat laging addition. Sum siya, hindi siya difference. And finally, for the last part, we have 24. Gawin na natin diretsa, 24 times 1 plus 15 times negative 1 is equal to 9. Ngayon, ano yung gagawin natin dito sa mga to? We are going to find an integer in the form ax plus by is equal to the GCD AB. And take note that your integers are 15 and 24. If you are going to settle with 9 and 6, they are not equal with our original value a and b. Dapat ang magiging itsura niyan, 15x plus 24y is equal to 3. We are going to find the values x and y that will give us 3. Now, how can we find the values for x and y that will give us the GCD 3? Gagawin natin, we have 9 times 1, taking this line here. Baguhin natin yung kulay para hindi kayo masyadong nalilito. Ano ba malinaw na kulay dito? Hanap tayo iba. Medyo naglalag siya. Wait lang lalag na naman siya eh. Kailangan ko na ng bagong computer. Palitan pati natin yung pen na pangsulat ko. Okay, so balik na tayo dito. Taking this line here, we have 9 times 1 plus 6 times negative 1 is equal to 3. We are going to write these values using 15 and 9 and 6 this time. So, 6 is said to be equal to 15 times 1 times 9 times 1. So, we are going to replace 6 here by these numbers. So, we have 9 times 1 plus, what is the value of 6? We have 6 is equal to 15 times 1 plus 9 times negative 1. And don't forget that we still have negative 1 on this part. So, lagay na lang natin siya sa unahan para hindi siya masyadong nakakalito. Lagay lang ako ng space dito. So, plus, we have here negative 1. So, simplifying this, we are going to end up with 9 times 1 plus 15 times negative 1. So, negative 1 times 1 is negative 1. Hindi na natin siya i-multiply sa 15. Kasi kailangan natin si 15 as a whole number. We are only going to play with the values for x and y. Yung mga nakikita niyong values dito, yung mga 24, 15, 9, 9, 9, 6, we are not going to touch those numbers. We are going to play with the ones inside the parentheses. So, we have here plus 9 times negative 1 distributed with another negative 1, we have positive 1 na, is equal to 3. We're not done yet because if you will take notice, we have 9 times 1 here and another 9 times 1 here. So 1 plus 1, you are going to have 9 times 2. Dalawa na sila. Dalawang 9 times 1, 9 times 1, magiging 9 times 2 sila. Just add them up. Plus 15 times negative 1 is equal to 3. Ayan, solve tayo dito sa 15 and 9. Akyat na tayo ng isa pa. Kasi, kailangan naman nating palitan si 9. So, ito naman yung kukunin natin. We are going to use this left-hand side, 24 times 1, 15 times negative 1, in place of 9. Papalitan natin yung 9 dito with this number. So, meron kang 2, twice niya. 9 is 24 times 1 plus 15 times negative 1. Iyon ang value ni 9. And do not forget that you still have 2. It is a factor of 2. Lagyan na lang natin siya dito sa unahan para hindi natin siya makalimutan later on. Plus 15 times negative 1 is equal to 3. You have here, sabi nga natin, hindi natin gagalawin yung mga values na ginamit natin for the quotient and remainder. Ang papalitan lang natin yung mga nakalagay dito sa parentheses. So, we have 24 times 1 times 2 is 2 plus 15 times negative 1. Ang papalitan lang natin si negative 1. So, distribute 2 sa negative 1. We have 15 times negative 2 plus 15 times negative 1 is equal to 3. Now, let's combine our terms. We have 15 times negative 2, 15 times negative 1, negative 2 plus negative 1, we have negative 3. So, we have 24 times 2 plus 15 times negative 3 is equal to 3. So, our value for x and y are, so x is 2, y is negative 3. That will give us the solution 15x plus 24y is equal to 3. So, let's check. Ano ang 24 times 2? Eh di yan ay 48. Plus 15 times negative 3. We have negative 45. Tapos ito ay equal talaga sa 3. 48 minus 45 is equal to 3. So, this is true. That is how you write a linear combination for two integers a and b, such that ax plus by is equal to the GCD of the two numbers a and b. Okay? I hope that was clear. Let's have another example to make it even clearer. Pagpasensyahan na, medyo mabagal maglipat ng sheet. Okay. Move tayo dun sa pangalawang example natin. On this part, we are going to start with 97 plus 16 times 6 plus 1. We are going to write this as a linear combination for 1. We have 97 times 1 plus 16 times negative 6 plus, is equal to, oh my god, sino itong nag-chat? Is equal to 1. Ayan. Sorry ha, may panggulo. Layo natin yung phone ko. Yan. Balik tayo dun sa pangalawa naman. We can write this as a linear combination wherein for the left-hand side, nandun si 113 at si 97, and for the right-hand side, nandun si 16 lang. So, let us isolate 16. Dapat nandito lang siya sa isang side. Tapos, mapupunta dun sa kabila. Ay, naglalag na siya. Ang pangit. 16. Dito sa kabila, dapat meron kang 113 times 1 plus 97 times negative 1. Yan. Papalitan mo siya. After that, dito naman tayo sa pinakang taas. We have 97. Dapat ang matitira lang dito sa kabilang side ay si 97. Then write this as a linear combination for 97 having 323 times 1 and 113 times negative 2 as your left-hand side. So, pag alam na natin to, pwede na tayong maghanap ng panibagong part. So, starting from this part, we are going to write 16 using the linear combination that we had from the second outline. So, si 16 dito, papalitan natin siya ng right-hand side nitong pangalawang linya ng solution natin dito. So, we have 97 times 1. I will give you a tip. If you see the 1 inside the parenthesis here, just write it doon sa labas para hindi kayo malito masyado. Kasi kapag nilagay nyo siya dito sa dulo, baka makalimutan yung nag-e-exist si negative 6. So, lagyan na natin si negative 6 dito sa labas ng grouping symbol natin. And then, write the ones inside the parenthesis. Yun nandito sa left-hand side. We have 113. Hindi gumagalaw yung ano ko. Hindi gumagalaw yung pen ko. 113 times 1 plus 97 times negative 1 is equal to 1. Take note, hindi siya equal sa 16 ha. Ito lang kasi yung equal sa 16. Ni-replace natin siya dito. So, laging ang left-hand side natin ay yung GCD na 1. Now, let's simplify. We have 97 times 1 plus, distribute natin sila, 113 times, negative 6 times 1, we have negative 6 here. Plus, 97. Negative 6 times negative 1, we have positive 6 is equal to 1. Now, let's count the number of 97s that exist in our left-hand side. 97 times 1 at saka 97 times 6. 1 plus 6 is equal to 7. So, this is equal to 97 times 7 plus 113 times negative 6 is equal to 1. After that, replace naman natin yung number na 97 using the linear combination for our outline here. So, meron tayong 7 dito sa labas, multiplied by yung 97 na nandito. We have 323 times 1 plus 113 times negative 2 plus yung natira dito, 113 times negative 6 is equal to 1. After that, distribute natin si 7 dun sa loob ng parenthesis without affecting 323 and 113. Ang maapektuhan lang yung mga nasa loob ng parenthesis from our outline. We have 7 times 1 is 7 plus 7 times negative 2 is negative 14 plus 113 times negative 6 is equal to 1. So, 323 at saka 7, wala na magbabago sa kanya. 323 times 7 talaga siya. But, for 113, you will see there two different values. 113 at saka negative 14 at saka negative 6. We are going to have here 113 times negative 20 is equal to 1. Now, let's check. For the checking, ito daw yung dalawang integers na magbibigay sa'yo ng 1. Where's my phone? So, multiply lang natin si 323 by 7. 323 times 7 is equal to 2,261 plus 113 times negative 20. We have 2,260. Siyempre, siya ay negative, which is equal to 1. 2261 minus 2260. Equal ba yan sa 1? Yes, equal yan sa 1. Therefore, our solution for x and y ay x is equal to 7 and y is equal to negative 20. For the linear combination, we have 323 times 7 plus 113 times negative 20 will give you the GCD 1. Next! Doon na tayo sa last na example. Ang hirap ng mabagal na laptop. Okay. Ayan. Ito, mas maikli ito. Dalawa lang yung linya natin dito eh. Bilis nito i-solve. So, for here, burahin natin tong side na to kasi hindi naman natin siya nakailangan. Na-solve na natin siya kanina. Mag-i-start lang tayo dito sa pangalawa, yung may GCD na non-zero. Ang GCD nga natin ay 19. Or may remainder na non-zero. So, itong 19, isusulat natin siya, green, as a linear combination of 133 and 57. If you multiply 133 times 1 and add 57 times negative 2, you will end up with 19. Dito naman tayo sa kabila. If you multiply 323 times 1 and add 133 times negative 2, you will end up with 57. Change tayo ng kulay. Ang kailangan natin ay si 323 at saka si 133. Hindi natin kailangan si 57. So, si 57, i-replace natin siya by the left-hand side, equating 57. We have 133 times 1 Again, pagka may nakita dito sa loob ng parenthesis, ilagay na natin siya kaagad sa unahan. That is just a tip so that you will not forget that you still have a factor of negative 2 at the back. So, lagay na natin siya sa unahan. 323 times 1 plus 133 times negative 2 is equal to, syempre siya yung equal sa 57. Pero, may 133 tayo dito. So, equal lang yan sa 19. Yan nandito. Ni-replace lang natin si 57 by this value. Yeah, simplify natin. 133 times 1 plus, distribute natin si negative 2 dun sa loob ng mga parenthesis natin. We have 323 times, negative 2 times 1 is negative 2 plus 133 times negative 2 times negative 2, so magiging positive 4 na siya. And this is equal to 19. Now, let us combine. We have 323 times negative 2 plus 133. Meron ka isa dito, 133. Meron kang 4 dito, 1 plus 4, 5. Galing. 133 times 5 is equal to 19. So, this is our linear combination for the GCD 19 using 323 and 133 as A and B. Check natin. Lagi tayong mag-check para nakakasigurado tayong tama yung ginagawa natin or tama yung isasubmit natin na sagot. We have 323 times negative 2. 323 times 2. Negative 646 plus 133 times 5. We have 665 is equal to 19. So, 665 minus 64, ba't ganito? Negative 646 plus 665 is really equal to 19. So, 19 is equal to 19. Therefore, our solution is correct. So, for this, we have x is equal to negative 2 and y is equal to 5 for our linear combination 323 times 323x plus 133y is equal to 19. There is an integer solution. X is equal to negative 2 and y is equal to 5. Okay? Alright. I hope that was clear. Thank you very much for staying with me for more than 30 minutes. Ano pa lang to? Euclidean algorithm pa lang to. Wala pa tayo sa linear Diophantine equations. So, please wait for my new video. Kasi yun naman yung susunod na gagawan ko. So, thank you very much and I'll see you next meeting. Hopefully later this afternoon. Thank you and bye!